introduce Mark Hansen. Well, if Mark Hansen will introduce himself. And this next session is Prompt Engineering 101. So we're going to try out all the stuff that we've been chit-chatting about so far. Mark, take it away.
Thank you. There we are. How are we today? Second day, we're happy. Oh, look, Rashida and Eric, that makes me so happy. All right, so these are the slides, if you want to grab them. It turns out if you write out the bit.ly code and you leave out the P, WHYP, you get some like German dentist's webpage. I love the bit.ly space and like what's next to each other in bit.ly. But anyway, so we're here to talk about prompt engineering and we'll just see how it goes. If you have any questions, if anything seems upsetting or whatever, like none of this is meant to be hard. This is meant to be like coding without code, right? So which doesn't mean that it escapes some of the coding principles, but and that's sort of where the engineering piece comes from. And Rashida and Eric, if something goes awry, you hold your hands up and tell me that this is wrong. All right, so because Emily called it navigating what's next or whatever, all of the pictures will be of pirate-like parrots navigating Times Square. It makes happy. All right, so what we're going to do briefly is start, and I apologize for sitting. It hurts, so if I stand too long. And so instead, I'm just going to show you. So we're going to start with the thing that happened first. Actually, I think I'm probably going to stand. The thing that happened first, because it explains a lot of the language that gets used. So the humble beginnings for ChatGPT was something, I mean, there was a GPT-1, but there was a GPT-2. And around 2019, this is when people in my lab started saying, oh my gosh, GPT is going to change the world. And it is going to be like such an amazing thing. Alex was like, this is going to be the most amazing thing ever. And it was basically designed, it's a kind of write-with interface. So I put a link up here at the bottom so you can try out what GPT-2 was all about. And it was like the AI that was too dangerous to release, right? And so you're basically typing along and it completes the sentence for you. And in this case, it was in a Donald Trump Jr. presidency, and then I let it complete the sentence for me. It says the government is more likely to treat Americans differently with the power to do what it wants in every corner of the country. Well, you know, some of those things seem right. And so GPT started with a very simple problem in the back of its head, which was, as I'm writing, what comes next? What word comes next? Right? It has all the stuff that you've written previously. It has all of the we'll talk about all the content in the world and where that comes from, but it's basically just trying to solve a prediction problem. So given a few words or tokens in a sentence, a language model, in this case a large language model, an LLM, GPT, tries to predict what comes next. It does this by reading a large amount of text, so books and news articles and websites. We've talked about this at length in this meeting as well. So it's learning about language, about words, about how they work together. And through this training, the model, which is just a tangle of neural networks, assigns probabilities to each token of what comes next. So the cat is chasing the, gives 70% to the mouse, 5% to the dog, 20% to the squirrel, about 0% to regret, right? So the next token then is then sampled from this distribution, and away it goes. So far, so good. It's a pretty easy, like, let's guess what comes next. And so in the process, though, we end up assigning probabilities to sentences. So sentences have certain weights attached to them. So the cat is chasing the mouse is bigger than the probability, has probability larger than the phrase the cat are chasing the mouse. And in that sense, then, it's learned some grammar. Similarly, the cat is chasing the mouse has probability greater than the antelope is chasing the mouse. And so we've learned something about the world and how it works. Finally, 2 plus 2 is 4 often has probabilities bigger than 2 plus 2 is 5, and you could kind of wish that it'll learn arithmetic, even though it doesn't exactly learn, like it's not so good with arithmetic. There are other ways around that. And so the obvious question then is, well, if it's just simply a prediction problem and that prediction problem folds back onto what it's reading, what is it reading? We don't really know for GPT-4 and beyond, but for GPT-3 we knew that it was the common crawl, it was a scrape of outbound links from Reddit posts, it was a couple of books databases, and it was Wikipedia. And this was the overall weights associated, like the overall amount of text scraped from each source. So the common crawl, that is just going across the internet and finding everything that's there, is huge in terms of the number of words or tokens that it found. Whereas little tiny things like Wikipedia are very, very small in comparison. The difference between the common crawl and Wikipedia is that the common crawl is full of like internet, right? It's full of the web, and so it's full of whereas Wikipedia tends to be a little higher quality. And so when it comes time to actually doing the training, the weights associated with it, or the amount of time the models spend with each of these, is much different. That was worth doing again. This is how many words they have, and then this is how much time it spends with them. So it's clearly spending more time on sources that are sort of higher quality, if you will. People have spent time curating, checking writing, and things like that, which has prompted Wikipedia. When we hosted Wikipedia Day here, they had these laptop stickers that Wikipedia has been training AI models since the very beginning, which makes me very happy. And we've already heard that there, like, great stories are told about what content and discovering what content is in these models. So the Washington Post had a great story, like looking at just the common crawl and what was in there. There's a site called Have I Been Trained? And you could ask for, do a search. Here I did a search for pirates, and it shows you all the things that are in the version of the common crawl for images and what got scraped, okay, and what's being used to build our jaunty little parrots. Not everybody's happy about this, about things being taken. There have also been sort of backlashes, people putting things into robots.txt. I think we talked about that a little bit yesterday. That's the sort of the only structural thing that people have to try to stop these companies from scraping their content, assuming they're playing by the rules. These are just a few robots.txt files from some local news sites around New York. So in general then, ChatGPT, these large language models, how they work is by reading a lot of text, and the basic prediction problem is what comes next. So again, it was imagined as a writing assistant, so you would, or a writing buddy, and so you would put some text down and it would try to predict what comes next. And the problem that it's solving is that sort of what comes next prediction. So far so good. Eric, Rashida, are we all right? Okay. Sorry, I should focus on others too. So there are several different kinds of interfaces one might have. People have experimented with, like, sort of walk along or whatever. This again was GPT-2. Now the thing that's been happening since GPT-2 is the models have just been getting bigger and bigger. So the complexity of what goes into that prediction is getting greater and greater and greater. The number of free parameters, if you will, that can be twiddled to say what comes next, to allow it to adapt to the sources that are there. So GPT-2 had 1.5 billion parameters. GPT-3 had 175 billion. Like, these models just keep getting bigger. Getting bigger and bigger, and at some point they become mixtures of models, so they become sort of multiples. So as the models get larger, things get better, and we'll talk about that in a second. GPT-3 was the moment where I went, oh, this is going to eat the world. So GPT-2, all my prescient students were like, it's going to eat the world. GPT-3, I was like, okay, now I believe it's going to eat the world. It has a playground that you can still play with, and in this case, you can see the prediction problem that's being solved. And it starts with the same sentence: in a Donald Trump Jr. presidency, ... I thought in election season we should, like, try try mixing it up. Maybe the Republican Party says we've had enough of Trump, put Trump Jr. Anyway, blah, blah, blah. And you can see here the words are colored according to the probability, the size of the probability. So the closer to green, the closer to 1. And then closer to red, the smaller the probability is, which means there's sort of just more uncertainty about where that sentence might go. And so it's making more of a choice. It's important to realize that these models are making random choices. You can set the temperature of this to make it not random, but out of the box, you will get different answers each time you run it, because each time it's tossing different coins associated with these probabilities. Does that make sense? Okay. So anyway, this is just playing around with it a little bit. And then some smarty pants discovered that this could happen, right? So suppose the text that you would like to predict isn't in a Donald Trump Jr. presidency, ... It's English : hello, French : bonjour, English : skyscraper, French : and you leave that part off. Right, and then the GPT happily fills in the French for skyscraper. Eric, this is French for skyscraper, right? Yes, great. And so in this moment, we have what's called a prompt, right? The text leading up to the answer, right? That's the prompt, and by completing the sentence, GPT is solving your problem for you. Right? So you want to know, how do I translate skyscraper into French? And if you set up your sentence right, or your prompt right, it will provide an answer for you. Right? And so this is where the word prompting comes from, right? That we are trying to prompt this thing to give us an answer. Is that clear? Okay. And the interesting thing is that it did really, really well on translation, even though the OpenAI people had tried really, really hard to get rid of non-English sources in the training set. They got rid of everything that was purely a language other than English. If it was a mix like some of these sources, then it was kept, and that mix was enough to have the translation work. You could also have prompts that were like asking questions, right? So what's the largest state in the US by landmass, blah, blah, blah. At the beginning, it wasn't very good at answering those questions, but it's gotten better. You could also give it text and ask questions about text. And then along the way, so what people were doing, in effect, was structuring a prompt that tricks this prediction model into performing tasks for you, right? That's what GPT-2 and GPT-3 were doing, right? It was structuring a document, structuring a prompt, so that by completing the prompt, it was doing a task that you wanted to do. It was translating or adding two numbers together or doing something like that, whether it did it or not, whether it was able to do it or not. The final ingredient that moved us from those sources to what we think of as ChatGPT and all the things that have come later is an explicit appeal to human feedback, right? The incorporation of how well a task is being done. So transitioning transitioning to what are called chat assistants, right? So we're now focusing on problem solving, not completing prompts, right? And this was one of there are 3, 4, 5 GPT papers along the way that are worth reading, because it gives you a sense of what they were thinking. But part of this shift from the older versions to ChatGPT and beyond is that they write that predicting the next token on a web page from the internet is different from the objective of follow the user's instructions helpfully and safely. Thus, we say that the objective of language modeling is misaligned. So there was an observation that there was a misalignment between solving a problem and predicting what's coming next. So there was some new emphasis on taking human feedback, right? Taking your response, thumbs up, thumbs down, thumbs up, thumbs down, and using that to shift the model a little bit to start to give you answers to questions as opposed to just completing prompts. Does that make sense? Okay. part of, just as a small aside, these large language models are really large and they are really opaque. It's not clear that they need to be so opaque, but they're really opaque in how they make decisions, how they predict what comes next. And so there's interesting narratives that come up around that are based on sizing and how big a model gets, because it looks like they're that these models exhibit what are called emergent behaviors. The idea that I can't translate anything, I can't translate anything, I can't translate anything as my model's getting bigger, 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 and then suddenly it's big enough and I can do the task. Poof! Right? Suddenly I can make scones, or suddenly I can do whatever, right? Like I'm big enough and like boom. And this happens all the time. And this is part of a narrative that you'll read about. This is the AI eating the world narrative, that at some point, because we don't know, when that kick up is going to happen, and we don't know if it's going to kick up and like kick us in the face, or it's going to kick up and like kick up its heels and like say ta-da, right? Like because we don't know the difference. It's a source of fear. Okay. So what we're going to do now is play a little bit and have you see the kinds of things. I feel like you got hints of this already, so we're going to just do it. How many chat.openai.com? Just go, yeah, so go to it. Open it up. What we're going to do is a little exercise that I did back in 2022. We were coming out of COVID. We were like, everything's going to be great. We're going to be out again. It's going to be awesome. And then monkeypox, right? And my friends and I started having to think about monkeypox and how and this is the way the New York State Department of Health reported its monkeypox statistics. Can you see this paragraph up here under update monkeypox in New York State? That was the way they were report. So after so many years of COVID and like all this like dashboard stuff, this is what we got for monkeypox. What do we think about that? Huh? Pretty shit. Wait a minute. I need to get my glasses on. Who said pretty shit? That's awesome. Thank you. Yes, pretty shit. Short end of the stick every time. Every time. But what makes it pretty shit? It's text with numbers in it. And how is that? How would you like it to be?
A table or a map or
a table or like a map. I mean, a map is like sexy shit, but like right, but like a map, like a table would be awesome, right? We spend a lot of time making tables, and by table I mean like maybe just a straight up Excel file, right? That would be great. This has got like a total of 414 monkeypox cases, and then it's got places. Those places aren't even in alphabetical order. Sometimes they're not referenced the same way. Sometimes they're not in the same order, right? It's just annoying, right? It was one of those annoying little things. And you can go ahead and click through on any of these web archive links and see for a given day what the update was. Okay, so what I'd love to have you do. Let's see here. So, like, here's what the rest of the world gets, right? They get maps. they get like histograms, right? Like who doesn't love that? And then we get this. So let's take actually just 3 minutes. Take a paragraph from one of these stories, okay, or a couple of them, and just tell me a story for a second. You only have 3 minutes, so find a couple numbers and tell me a story about monkeypox in New York State.
And if they don't have the slides open, so like the bit.ly link at the beginning.
Oh yeah, let me put the here. If you don't have the slides open. here it is again. Okay. So it's, oh, the bit.ly link is so small. Let me make it bigger. Oh, but I'm just viewing it. I can't make it bigger.
That's okay.
Okay, anyway. And I tell you, it's 3JQWHYS, and if you leave the Q off, you get this, it looks like a German medical professional. Anyway. All right, are we okay? Can we look at?
What we've done is I've passed out a bunch of red sticky notes. It always sucks to be in a technical session and like super stuck. So if you're really, really stuck, just put a red sticky note on your computer. And if we see a sea of red, we'll stop or I'll come by and help you.
Or we will laugh evilly.
Yeah. So if you're not sure what you're doing or what to do, just put a red sticky note and we'll come by.
Are we all looking at a New York State number somewhere? I get a yes. I get a yes. Doesn't have to be a super intense story. Okay, what have we found? It could be like a super low, like in Westchester County on July 28th, there were this many cases. That'd be enough. That's a story. Something? No? No? All right, there's something in that.
Do you mean what ChatGPT spewed out?
No, because we haven't ChatGPT'd yet. But
Oh, I totally did that. Sorry.
okay, great. So you are ahead of the game. I just wanted to like have us play with the numbers for a second. So we see here that in July 14th, there were 414 confirmed cases. If we go to July 15th, we'll see that there's 490 confirmed cases, right? So I could, in principle, July 15th, we're up to, still 490. July 19th, we're up to 679, right? So the numbers are just like getting bigger and bigger and bigger and bigger, right? Do we see that? That's a story. Holy crap! These numbers are getting big. Okay. All right. Great. So, so what? In terms of thinking about this as like a story exercise, right? So suppose your beat is to cover monkeypox in New York State, right? What is your plan, given this website? What is your plan?
To just make a chart that explains the growth.
Great, but like, so every day there's another one of these things. So what is your plan?
I'll synthesize and summarize all the information.
Right, but like, so you get up in the morning, you got your coffee, right? You're on your beat. You go with your laptop. I'm on my beat. What do I do? And what tools am I using? What am I? am I typing things out? Is there software I'm using? Well, I'm using the browser to get to this page. What else am I doing?
You're gonna have to build yourself a little spreadsheet so you can track it changing over time.
Thank you. You're gonna have to build so what often happens in my classes is I ask really easy questions and the students just look at me like, you are so stupid. Why are you asking me this question? So we usually have a signal for that in class. It's like, like stop. So when I get like that, just stop me. But yeah, so we're gonna have to have a spreadsheet. And every day we're gonna have to go through, and hopefully the same counties are mentioned. Monroe County isn't always mentioned because it doesn't always have a case, so we'd have to put a 0 in there or something like that. Okay, so there's some things that we're going to have to do as budding data journalists on a monkeypox beat in New York State, and so this is basically what you need to do. So you're going to have to save that page from the New York State Department of Health. Perhaps you just put it on the Internet Archive, right? They have a save feature, so you can like save that page and make sure you have it. So you have the primary data, right? So we'll save that somewhere, maybe put it in a folder. Next, we need to translate that page from English into something more usable, right? So putting it into a spreadsheet, as you suggested, would be great. So you can then store that growing table somewhere. Maybe it's a table that you could like share with your friends in the newsroom, and so that they could take the graphics that you were given and be excited about it. And then this is a classic case of taking unstructured data and making it structured. Okay. So what we
The stream can't hear you without the mic.
Oh. Hello, stream. So this is a classic case, like I said, of taking structured data from unstructured observations. So by unstructured, I mean this is just like 414 cases, 12 in Westchester, 4 in Suffolk. It's just loose. It's just text, right? There are lots of examples of data that come like that. In fact, a lot of the stuff that you read, like there have been a number of projects that try to look at, I remember a great one we covered in my data class on, great in the sense that it was thorough and well done, on anti-Asian hate. And it looked at news reports, and from those news reports extracted where it took place, what took place, what time of day it was, that sort of thing, right? So there's content, there's data, there's things that fit in columns of a table in a news story. You just got to work a little bit, right? And so here, that work is just annoying. Like I saw that work and I went, ugh. That's just like unnecessarily annoying. So when I first did this, it was the fall of 2023, and you might want to try to translate this paragraph into something more usable. So let's see if we can do that. Let's open up. So we can open up this, and then let's take our text, and let's see if ChatGPT can make it into something. How we do that? Okay, I can do that. I'm good at that. Step 1. Let's put this in here. Okay. Again, what we want to do is have we want to have a question so that it comes back with something for us, right? Right now, the scratchy thing is we've got this paragraph, right? What we want is a table, right? Can we just ask for a table? Okay, so give it a go. Ask for type.
If you don't have access to the bit.ly, I've put it on data4news.com. Data4news.com. And the link
Look
is
at that.
on just looks like this. stuck, just put the red sticky on. I'll come by.
What did we do?
Oh, we got it.
Okay, great. Did anybody else try something? Yeah, yeah, yeah. Oh, look at that, hands. Look. Okay, what did you do?
I asked the strange machine to make a table of New York State monkeypox numbers.
Okay, so make a table of New York State monkeypox numbers. And did you separate it away somehow a little bit? Like,
By county,
oh, okay, sorry. So what was your full prompt? Like, what did you type in?
make a table of New York State monkeypox numbers separated by county of origin.
Okay.
And it just gave me a random year, 2021. I didn't ask for a specific year.
Oh, right. Well, and you typed in this text, right? I mean,
Yeah.
you put, yeah, so that was just going to do 2022. That's all it knew how to do, right? So that's not bad. What do we think of that? I don't know. I feel a little happier about that. I said, huh? Is it right? Oh. I think I would have thought after all of yesterday, the first thing you would have done is to decide, is it right or not? Is it right? Yeah, I got it right. Yes. Okay. So what just happened there, by the way? That is it right? How much time did you spend? Oh my God. I'm hobbled. Can't I have like a dispensation from? All right. Just out of curiosity, when you think about workflow, and that's what I was trying to get at back with this slide, you're thinking about workflow, right? The idea of translating the page into something different, that is like a table or a spreadsheet or something like that, right? To be able to do that reliably means that you somehow need to make sure that the answer is right, right? In many cases, it will make mistakes, right? It won't give you the right thing. And this is where we're going to get on to the idea of prompt engineering, in the sense that sometimes refining the prompt will increase the probability that you get the right answer. In this case, we got the right answer out of the box. Or did you try other things before this one? Oops, did you try other things before this one? No. All right. So hire her. You're a new prompt engineer. They make $300-something thousand a year. It's awesome. Okay, so everybody, so verifying has got to be part of your workflow, and how you do that is something you're going to have to think about, right? So in this case, they're small enough numbers so that every time you can give it a try, right, and just like look and compare and make sure that it's all there, and away you go. There are other things where it almost seems like as much work to go through the thing in the first place as it is to have the AI help. So because journalism bears that burden of, yesterday, who was saying that they wouldn't accept 99.9%? Whatever, a little part of me as a statistician died in the process, but like whatever that number was, if you're going to need that level of precision, you're going to be spending some time with error checking, and so you better, Bert, what's wrong? Right, but humans also, there's lots of things that humans don't do that don't justify AI not doing them also, right? Like so, and it goes the other way too. There's a lot of things that, because a lot of things that humans do are why AI does what it does. But anyway, okay, so that's just something to think about. Here's the prompt that I did. I said, here's a paragraph summarizing the latest monkeypox statistics from New York State. Create a CSV, that's a comma-separated values field. That's maybe, we don't need to talk about that, but it's a form of a table where each line in the file is a row of data and the elements are separated by commas. And I wanted to have, I wanted the date and the place and the case count, and I gave it the table a header. Let me just boost this up a bit. So I said, please give me the date, the place, and the case count, and then I want the header of the table to be date, place, case count. And so the table that I got had date, place, case count. Okay? Because I wanted a little bit more structure. Because if I do this tomorrow, because this is your beat, right? When I do this tomorrow, I'm going to want to add the next day's data to this. So I'm going to want the date to increment, right? So I'm going to want a different date. So then I can like make plots and things like that. Does that make sense? Great. All right. So there's some things, even in that simple example, there's some things about prompt engine, like you're asking for something, right? You're asking to do something, and the thing is providing you an answer, but it doesn't know what you're going to do next, right? Like it doesn't know that I'm going to want to take 4 of these or a week worth of these or whatever and make one big growing table out of them. And so it'll give you something, but it may not give you the thing that you're the thing that's deep in your heart. And so here I've given it like a bunch of things, like you could pair this with whatever. And again, give me date, place, case count, and it gives you the different dates, places, case counts. Again, now checking is a little bit more irritating. Over time, you start to rely on your tools in the same way that we learned how to ride a bike somehow, and we only fall off once every 0.1% of the time we fall off the bike. I don't know. Anyway. The other thing you can have it do, which I will talk about a little bit, is here's like where are the biggest changes in monkeypox occurring, right? So I had it read in the monkeypox data and then had it do some analysis for me. What do we think about that as a task? Yeah.
Seems a little vague and open to a lot of interpretation. So you might want to, I don't know, define it more in terms of the specific levels of increase or specific levels of increase, and then say, do a chart, putting up the cases in which there's the greatest level of increase in different colors. And there's a lot of
Awesome. So you are engaging in a joint action with an AI. I hate the idea of the notion of collaborating with an AI. So you are undertaking a joint action with an AI, and you share a common goal, and you are trying to get it to do these things with you. And there's an iterative process here that mimics the data analysis process, right? So we're going to come back to that in a second. So I would say that asking it to do open-ended data analysis is a bit like asking it to write a paragraph for you about the War of 1812 or something, right? It's going to kind of go blah, 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 and it won't be that exciting. But there are things that we can ask it to do that are more exciting that will get us farther along in the story. Eventually, by the way, we did get tables and things like that. So New York State somehow was like, oh, we know how to make tables. So far what we've seen is prompting is you're specifically asking for some task to be conducted on some data. Right? You probably came into this thinking about prompting and prompt engineering is like, how do I get it to write a better paragraph for me about the War of 1812? I don't want my students doing that. I don't want them using it for writing. Like it's not that I have like some moral, I might have a moral objection, but like it's not, this particular position is not coming from that. It's coming from the fact that there are so many interesting data things that this system can do when prompted that we should spend some time thinking about that, right? That the affordances that are offered here to small newsrooms, to journalists just starting out, there are things that you can do with this that make it that make it worth the price of entry. So this is a recent thing that just came out. It's a bot that Hearst, the San Francisco Chronicle, put out about all their coverage of Kamala Harris. And it's a chat bot, so you can ask any question you like. And my first question for these chat bots is like, where do I get a pizza? Because if they don't put enough guardrails in place, that you can start talking to this, helpline about pizza and other things, right? And this, of course, comes back. Actually, it did a nice job with the pizza question. It says, I don't know anything about pizza, but she does have an opinion about burritos, and it went on about burritos. But these are the things that they use the AI for in terms of how to manipulate the prompt. And this, again, what I'm trying to do here is just layer on ideas about how one makes a prompt and the thoughts that go into making a prompt. So here, for example, they're using a moderation check. So if you type something like rah 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 rah, it's going to use a moderation check on the prompt. Sometimes rewriting the prompt is a strategy people take, and other times just dropping it. Right? This is offensive, and so we're not going to have it. There's a relevance check. Does the question have something to do with the presidential campaign? So here they're again taking the prompt and making sure that it sort of satisfies some basic criteria. And then sort of apropos of yesterday's the last comment, or the last session yesterday, if this is about voter information and someone's like, how do I vote for Kamala Harris? They're like, we'll redirect you to a website, which is probably the safest thing to do, or that's what we heard yesterday was the safest thing to do. Here's another example of like how prompts get put together. So all of the separators in this slide deck are DALL-E 3 parrots in one form or another. I don't know, I was tired. And so I asked, make me an image of a parrot on a pirate ship. And it gave me that. And if you try to download it, what you find is that the image has a name, right? The image name in this case is a vibrant parrot perched on the wooden railing of a classic pirate ship with colorful feathers. And I was like, what? So what's happening here is that when you ask DALL-E 3 for an image, the first thing it does is go to GPT-4 to have it enhance your prompt to make a better image, right? So me asking for a parrot on a pirate ship was not expressive enough. So in this case, I was prompt edited, and it provides this prompt. And in fact, the full prompt is this. So a vibrant parrot perched on the wooden railing of a classic pirate ship with colorful feathers, green, blue, and red. The pirate ship is weathered wooden planks, large sails and ropes. In the background, the ship is sailing in calm ocean waters with a clear blue sky. But all of this is like happening in the background, right? I didn't type any of that. I just said I want a parrot on a ship, right? And so the prompt, this is what's known as shadow prompting, and it's a way of sort of rewriting, and it's OpenAI's way of saying, well, you said this, but you probably meant this, right? And so again, prompt engineering, this time in the hands of the system itself, right? And what does that look like? There's another reason why this sort of prompt rewriting happens with DALL-E 3, and this came up yesterday also. So this is a piece by Bloomberg about what you get for images from these generative image models. If you ask for a color photograph of a CEO, or a color photograph of a dishwasher, or this is toys in Iraq, or playing soccer, give me a portrait of a person playing soccer or cleaning. So there's a lot of biases that are built up here, and to try to train away the biases, DALL-E 3, it's worth spending a little time with this thing called the system card. So all of the systems have a little write-up. Have you guys read, Rashida, Eric, have you read the Okay. So for DALL-E 3, it says, these are all the things we do to make DALL-E 3. How many use DALL-E 3 or have used it? One? Meg nod, yay. And the reason they had to do the prompt rewriting is this. So this is from the system card. The top two pictures are delete 3 before it's prompt edited and delete 4 after it was prompt edited. And the prompt here is Sarah's face captured in detail, showing her wide open mouth and arms folded near her chest as if shocked. And sort of DALL-E 3 just coming from, well, internet, looks like the person on the left, and DALL-E 3 with a rewritten prompt looks like on the right. And then here, same deal, but the caption or the prompt is an individual enjoying a leisurely picnic in the park with an array of snacks spread out on a checkered blanket. And then that's what you get before they brought it in. And I'm like, what? Like, internet, cool it off, man. And then as opposed to here, where, I guess delicious. I don't even know where most of that food came from because it wouldn't fit in the basket. But anyway, but the point is prompt engineering, right? Prompts are super important, and the more precise you can be about your prompt, right, the better. And that there's a layer in which that kind of prompt engineering work is happening by the systems themselves. The platforms themselves are using that prompting mechanism to kind of cool it down a little bit, right? So it's not so much just unvarnished internet imagery. All right, so then in broad strokes, I think I'm doing okay with time. Are you okay? Okay, are we okay? Are we? Okay. No, I mean, it's like generally. Are we all right?
Oh, yeah.
Are we? Okay. All right. Are we good so far? Is there? Did you have any questions so far?
You can bring a mic around if anyone has any questions.
Just thought we should take the temperature because it's cold in here. All right. So this is what OpenAI thinks about strategies for prompting. And again, prompt being that old word that comes from how do you set up that sentence, the start of which tricks the system into giving you an answer, so you've prompted your way into it. So there are some strategies. A lot of it has to do with clarity, so writing clear instructions. What do you want to get on the other side? What kind of output do you want to get? What should it look like? That sort of thing. There's something about using external tools, and by that I mean the latest round of these large language models imagines them not as assistants but as agents, right? So you send them out into the world to go solve problems, and we'll see an agent in a second. So maybe use some external tools, especially about the math. Break complex problems down. And then there should be, it's not in there, okay. And give the model time to think. It turns out if you add the phrase, let's reason step by step, right? You prompt it to give its rationale. Now, don't think for a moment that this is actually why it's doing what it's doing, but it'll tell you something about what it's doing, or at least give you some clues as to the words that are being invoked in a moment. So these are some of the things that that OpenAI suggests. Some of them come from some basic programming. Like, the great thing about a programming language is that it's very specific about what you're supposed to get, or many programming languages are, right? Or if you program them well, there's certainty in what you're supposed to get. And so some of these things are trying to take working with an AI system and making it feel a bit more like coding, right? Some of that idea. other sources, I just started like trolling around for like what other people are thinking about contemporary prompt engineering. Some of the things you'll come up with again and again, like I said, clarity is super important. Constraints are super important because 9 times out of 10, it's not going to give you a nice table. 9 times out of 10, it's going to give you something else. And then you're going to be like, oh, so how am I going to catch that? Sorry. 9 times out of 10, it'll give you 10. 1 time out of 10, it'll give you something else. Also, up here, try role-playing. Role-playing is usually awesome, right? So don't just let GPT be what GPT is. Say, you are a banker interested in, I don't know, tracking interest rates and whatever. And that positions the prediction problem in a place where, like, again, we're building up text that's supposed to be what comes next, and if part of what comes next is an awareness is some sort of verbiage that refers to a particular profession or a particular way of doing things, then you end up sometimes with very different answers. Again, slightly thieved content, but so prompt engineering is a programming language, like you can just call it what it is. Because here we're manipulating with data, right? And so when we write prompts, we're coding. And most of the time, when you're just sitting down in front of GPT, that's fine, right? You can do whatever you like just play with it, right? That's what OpenAI wants you to do. Just sort of play with it and see what's there, and you'll ask it a question and it'll say, you know, Jennifer Aniston, and you'll go, no, I don't mean that, friends, I mean somebody else, and like you'll go back and forth. Sorry, you'll go back and forth in that conversation, Rashida. You'll go back and forth in that conversation, right? And refine until you get the thing that you wanted, right? But then there are situations where that's not good enough. So suppose we want to use this thing to do something like with the monkeypox data, and I need to share that with somebody, right? So now I need to share my prompt with someone, right? And so that means that I might want to have some more sophistication around, like someone isn't going to sit there and type around it. They're going to want to just execute the prompt that you have and get an answer, right? Which is, again, more like coding than it is like chatting with somebody. So yeah, again, once you start to share things, it's not just banging away at something. Also, increasingly, because of the problems with the large models, you heard everything from economic problems, environmental problems, lawsuits, all those, like OpenAI. How many senior members left yesterday? Like 4 people left. So there's a move, especially in journalism and other places where the data are sensitive, to use open source models. So models that you would run on your laptop or on your computer at home, so that the data don't go anywhere, they stay with you, right? And in that case, those models aren't as powerful as some of the ones that are like the industrial strength that require 5 football fields of computers to do the work. And in those cases, you're going to have to really refine your prompt and really get specific about what you're asking for, because those models aren't as smart as the other models, right? So the prompts that you're going to have to put together are a little looser. And then scaling, which we can talk about later. Okay, so some of the strategies then, because I want to get to a place where we're going to play a little bit. So we've seen some of these basic prompt types already. So like in the translation problem from French to English, one thing I could do is simply what's called a zero-shot program or a zero-shot model. And so it says instead of like it just says translate English to French, and it says cheese, and invites the system to translate the word cheese. A one-shot is like what we did before, which was sea otter is, I'm not going to try to pronounce that. Emily, can you give us the French? Okay. It sounds like I can't even read it, which is a shocking overlap between English and French. So sea otter and whatever sea otter translates into, and then cheese comes next. And then few shot says, I'm going to give you a few examples of what it is that I'd like you to do, and then do it. Okay? So there's multi-shot prompting. There's also what's called chain of thought prompting. I mentioned this before. So you add the magic let's think step by step, and it suddenly is able to solve some problems that it couldn't solve before because it's taking a moment. With a lot of these things, changes in the prompts feel a little bit like voodoo. And there are so many papers that are advocating different ways that you can like tweak the prompts here and there to get it to do something better, especially around math. There was a lot of that happening. Anyway, chain of thought prompting was another. There was one about the AI sounding too confident. So if you start your prompt, or again, like this idea of the prompt, if you start your sentence, the part that you want the system to come back with is, I think it's, or allegedly it's, or around this. Like you start with some words of uncertainty, then it sort of better addresses the uncertainty in answering the actual question. Again, these are all, the way these studies happen is that you have a set of tasks and you have the system perform these tasks subject to these constraints on the prompts, and you see how many times it gets it wrong versus right. So it's a kind of like, is it doing better on average? Let's see here. Oh, and then there's, does GPT do better if you offer it a tip? So if you offer, like here it's asking, saying you're a world famous writer, respond with a unique story about these subjects that a user provides. The story must be exactly 200 characters long, no more than 200 characters, no fewer than 200 characters. And the question is, does it do it better? This is the length here, so it's not getting close to 200, but does it get better if you offer it a bonus, like $500 tip or $1,000 tip or $100,000 tip? Is it and it's getting a little better. I don't know. It's like ChatGPT. Or would you like to spend some time with Taylor Swift if you do this right? Or world peace, or love, or chocolate, or heaven. And then of course there's the other side. If you fail to provide a response which follows all this cringe, you will die, right? So if you threaten it with death, or death in capital letters, or getting a bad case of COVID-19, or losing all your friends or your job, does that like incentivize it to do something different? These are very small effects, but anyway, the idea is a little bit of prompt changing. Can we affect? And I would say the biggest degree of prompt changing is going to be simply being very clear about what you want. Here's another example of kind of a mix of data, like knowledge that the system knows because it's hoovered up the internet, as well as some translation. So one of the students in my data class wanted to understand something about jazz musicians in New York City, and at any given evening. What's the gender breakdown of jazz musicians on stage? I'll just tell you, hint, there's not a surprise at the end of this. So we did a web scraping exercise where we pulled a bunch of data, and then what we got was a series of who the people were, like a vocalist, Joe Davidian, piano, Jennifer Vincent, bass, Bruce Cox, and so on. And then the question was, could you turn that, could you add to that a column that had the gender associated with it, right? And here what we wanted to do was not have it guess the gender based on the name, like Joe or something like that, but instead, these are public figures, right? So a lot has been written about them. So there should be some text that would make that an approvable thing. Let's see. Let's give this a try. Or should I not do that? Okay. So I get a week. I will do it, and then you will do it at home. How does that sound? doesn't sound so good. So one thing we could do, I'm going to Google Sheets, and I'm going to get an extension, GPT for Sheets and Docs. Here it goes. We'll install it. Oh,
I think you can just use AJ's.
you think I can? Okay.
Or, yeah, I don't think, if it's going to take a while, we can just
Yeah. Okay. We'll animate through this. I'm getting a little nervous using this guy's account. Anyway, but the point of this is that oops, not share slideshow. We have something else we can run instead. The point of this is you can install GPT for Sheets and Docs, and what it does is it allows you to run GPT down the columns of your data set. So here we opened it up and installed it with GPT 4.0. We loaded the data from that we just saw. That has the artists broken out and so on. And then this last column, pronouns, was created by using this prompt on the side. So there's a function with this that you enable. So the first row with the function, the prompt was, this is a well-known musician, given what's been written about them publicly, what pronouns do they use? Please answer only with their pronouns and no other verbiage. And the musician is : and then it gives the name of the musician from column F, and then it fills in there. It goes one by one, calling GPT to fill in there. So for those of you who want to use GPT to things like, there are other things like tagging data. So here, for example, we have a bunch of tweets from a press secretary of the governor of Florida, and we want to classify them into one of these categories. The GPT for Sheets and Docs has a function called GPT tag, and you just give it a list of the possible tags, and then it'll go down the column and assign each tag that it thinks the text in that column might be. So what I wanted to show here was simply that the idea of prompt engineering, the idea of taking your prompt and applying it to process data, here we're doing it across an entire spreadsheet, right? And you don't really have to code anything, right? There's none of this. The quote unquote code here is in the writing of the prompt, the generation of the categories, or back here it was the phrasing of the pronouns and how do you just give us only the pronouns. Okay, is that all right? So that says that this can live outside of the little box that you get from OpenAI, but can be something more. Okay, there's a lot of work on how to make your prompts better. Everything from A/B testing to different kinds of guidance that incorporates all of the study that people have been going through to try to understand how these large language models process requests. I'm gonna pass by that. And pass by that. The thing I might end with is if can I have like 4 minutes? Okay. I'm gonna end with a GPT-4 thing. No. Half the time I just give my okay, and there was a okay, so this is about the easiest data set you will find. It's just the data that are available about city bike rides. Can't get any simpler than that. And this is going to give you an example of the sorts of things that I use this for on a daily basis. So the city bike data, every row is someone renting a bike. Okay, very simple. There's the station that they picked it up on, the station they dropped it off on, the time they picked it up, the time they dropped it off, whether it was an electric bike or not, and whether they used a credit card or not. Okay. Yeah. Thank you. Old guy falling. Let's just with that as a background, what questions do we have from this data? Because this isn't about like brain functioning of rats or something like that. This is just renting a bike. The average distance written. So let's fall back on that for a second. Is that a question we can answer with these data? Suppose I pick up a bike, I go shopping, and I come home and I drop my bike off. Pardon?
Maybe not.
Okay, that's fine. Yep.
What's the most frequent one for ridership?
Great. So so we can then just ask, this is a data set of city bike rentals. Each row is a bike ride. What station is used most often? That's bad. What station, from what station do most rides start? Is that okay? So it will do its thing. Forsyth and Broome Street is the most. Do we know that one? Have we rented a bike from there? Anyone? Someone? I would hope the most popular one would. But the thing that happens here is that this link here shows you it says to find the most common. Oh, come on. It says to find the most common start station, we'll group by start station and then count the numbers. So it has taken in the data, it finds a column called start station name, it counts up the numbers for each column, for each of the counts, and then it finds the name of the max. So what it's done here is it's taken the question that you had, it has turned it into code, it has created a secondary artifact that I can now check. So as a Newsroom workflow, I may not be like the most confident coder, right? But with help here, I can build up a data analysis. I can keep the code, and I can show the code to a buddy. I can show the code to someone on a data desk if my Newsroom has a data desk. If my Newsroom doesn't have a data desk, my city, town, or borough is going to have a college, university, community college, high school, where there is a statistics instructor who would love nothing more than to help you with the work that you're doing. I swear to you, I was that statistics professor who just sat in his office waiting for someone to come by with a question. So happy to be useful when someone came by with a question. You will make a friend for life because no one thinks to talk to the statisticians. So you can then start to take these to build this up. We don't have time now, but I've had sessions where we use this data and people have asked questions like, find for me the station that is farthest away from a subway station, right? So like, or find the subway station that is farthest away. You can make maps. You can, like, there are lots of graphics and things that you can make as well. In fact, Dramil will walk you through how to make some sexy graphics from the data. Again, all of this is happening because, and we have a little more trust in it because the AI is authoring a secondary artifact that you can check, as opposed to it just doing its magic and saying, Forsyth and Broome is the street, is the station. Okay? Yes?
So quick question, the CSV dataset is something you put together, or you found this data somewhere? Or
Yes, the City Bike puts it out every day, so, or every week, I think it's super real time. Yeah. Other questions? Yes.
The scariest part was when you first asked, are you right about what they get? The information you're providing and statistical tool you're using. But is it not also same with the when you run codes? Like sometimes we got false negative or false positive. So what is the chances that I will get the false negative or false positive or false results in this way? And what is the best? I know you talked about prompt engineering, the way we can avoid is if there's any way that we can be more secure and such.
Right. So here, like generating code for me, like this is how I've gone over to teaching my classes. Right. I've learned that it's easier on the students if they learn how to read code than necessarily having to write code from the beginning. Eventually, I want them writing code on their own, but at the beginning, you know, it's okay if this thing writes it and they can read it and go, okay, and it'll give them lots of comments. They can ask for comment. That should be part of the prompt. Please give me comments. I love them. And then you'll be able to see what's happening, right? And if you can't read it, come to office hours and we'll figure it out, right? But the nice thing about this kind of, and there are a few places where this happens, where the thing that's being produced is not just the AI magic, but it's a thing that you can then use somewhere else, and that other secondary artifact can be checked, right? And that to me seems important. Okay, I'm gonna just finish. I don't think there's anything here that I can't zoom over. Except to say that, like, just because you can ask it to make code doesn't mean you get out of the bias problem. Here we had some survey data, and we were looking at a bar chart of the birth years for people who responded to the survey. And I had seen these beautiful, what are called pyramid plots from the Census Bureau. So I asked GPT to make me some code to make a pyramid plot for my data. And it did that. So what's the difference between that and that? The pink, right? So suddenly this like gendered color scheme comes in and you're like, oh, GPT, like it's not a half naked guy on a blanket, but come on. And then there's a bunch of other references here about different tools you can use, and the ways in which things are headed in terms of open source data and that sort of thing, and more stuff about bias, things that even GPT-4 had, like tell me a story about a doctor and a nurse, and do that 10 times, and tell me how many times the doctor's a boy and the nurse is a girl. Like it's still, anyway. Yeah, so that's all I got. I hope this was helpful. Thank you for your time.